then it cancels out, and then it's.
Five, 4, 3, 2. See if it works. 1. Oh, nothing? My buzzer doesn't work. All right, beep, beep, beep. We'll just count it. Kiddos, after you, I could use my hands. Okay, so, give me back. Although one of them's kind of, Krista had too much fun last year. Anyway, coming back. What do I do? In normal division, once I write a number up top, signifying how many times it went in. Now what? Multiply, and if it's a binomial, multiplication to be legal must distribute, right? So you not only get an x cubed, but you also, everybody, get a 5x squared. In division, just with normal numbers, when you go to now perform the next operation, what do you always do? Subtract. But since I'm subtracting the whole binomial, to legally subtract, I would need to distribute the negative on the inside. So then, I know, pretend that's a minus. That one cancels, and I get a negative 5x squared. Check it. Did you get the negative? If not, you can close it. In division, once we have a new statement, we say how many times, once again, will the outside go in? Hopefully we got it. Did you get the sign right?
No.
Do you see why?
Yeah.
I wasn't paying attention when you said it. Now I need to distribute. Negative 5x squared minus 25x. Do you see how I have it all nice and lined up?
Yeah.
So I could bring down the plus 0x, so I can now, see me bring it down, so I can combine like terms. Does the 0x really make any difference? Not in this one, but it will in others. To legally do division, I would then subtract. But for a binomial, what must I do? Just distribute the negative. That's not a big deal, right? We just forget it sometimes. Then, the first cancels. What happens here? Positive 25x. Some of you might already be thinking, I bet I'll use him next and rewrite him. That's not a bad idea. But we still just look at the outer term and say, how many times? 25. A positive 25, right? Are we okay? So then multiplying, distributing again, 25x. For those of you that aren't so hot at mental math, 5 quarters will be $1.25, right? Or 5 times 25 is 125. To legally divide, I should do some subtraction, and to subtract a binomial, I must distribute, keeping everything legal. Cancel. Cancel. Remainder of 0. So question, Ricky, did it go in evenly?
Yes, it did.
Nice. So what last year was same, opposite, always positive? If I was to rewrite this problem, give me just 1 second to demonstrate. Calm themselves. I'm pretty sure I wasn't that entertaining, which means you're talking about random nothings. Or at least right now, shouldn't be anything. That's the problem, right?
Yeah.
On the left equals the right. We divided, we got the answer. What else could we use this for, besides just dividing?
Factoring.
Because I can move around this equation just a little bit, and I could multiply this to the other side. Hence, I could say x cubed plus 125, 2 perfect cubes with a plus in between. Factors to be, take the cubed root of 125, the sign stays the same. X squared minus, that same number x, the sign is opposite, plus 5 squared, if I can get it there, and the sign is always positive. SO8. Anyway, how to factor a perfect cube. Binomial? I don't know. How to factor the sum or difference of perfect cubes. Anyway, that's what was going on with SOAB from last year. And by the way, this is what we're getting ready for, but the nice thing is, in section 2.3, it doesn't really require you to jump to figuring out factors yourself. It just kind of gets you really good at long division and synthetic division. Yesterday in our notes, composition book's open, we started a division problem. Wait. Yesterday in our notes, we started a division problem, but we didn't get to finish him. But I hope after our spiral work, now you can. So, you've seen me explain an entire long division problem. We're back in our notes. Can you go ahead and try to finish it? We started. You try to finish. Ready, set, go. In your notes, finishing the example from yesterday. Let's see how far you can get. Take what you just saw, try to apply it. There he is. Sometimes it could both, but usually not. If you reach the end, just kind of peek at your group's composition books and see if they agree with you. Make sure you didn't kill any seals. I'm gonna pick it back up. Hopefully as you guys, some of you might not have even gotten this far yesterday, hopefully as you're writing, it's making more sense why we did what we did. Why we have a negative 8x squared, because it was negative 3 minus 5x squared. Did you guys go ahead and put a negative 8x next?
How'd you get that?
Do we need the x?
No, it's just negative 8.
So it's just gonna be negative 8, good.
Didn't you skip the x for the, you can't put the x cubed?
We skipped the x.
Because aren't you supposed to put the x and skip the x cubed?
It's a 0, so he's not even there.
Oh.
We put it to leave space just like the last one in case we needed it.
That's where I messed
But in
up.
this one, it's 0 and there's nothing to combine. 0 plus 0 is 0. Right? 0 plus 0 is 0. I can put it plus 0 if you want. That's gonna leave. Right?
Why does the x squared just go
Yeah, I could go with.
Oh, because when I multiply, there's an x squared in the problem, so he's going to come when I multiply by negative 8. Does that make sense? The x cubed goes poof. That's what I've heard some people saying, why not the cube? He's a 0, so, and there was nothing to combine with him, so he's gone, he's done. Now I distribute, negative 8 times 5 is negative 40. So did I really need the 0x in this problem? Maybe not, but did I in the last one? To keep my places, yes, I did. So it just depends. We play it safe so that we can get it right every time. So we go ahead and put those zeros in, but sometimes they're not so necessary.
That's harmless.
Now, dividing, I need to subtract. Subtracting a binomial, I need to distribute the negatives. My 8x squared minus, sorry, my negative 8x squared plus 8x squared is 0. The 0 plus 0 is 0. Or 0 minus 0, either way. And negative 1 plus 40 is 39. Can x squared go into 39? No. So therefore, who is he? And how do we mathematically write a remainder? Divide by true. 39 is the part of who we're dividing by, the whole. But what do we put in between? Is it times?
Multiply. No, it's plus.
Just think, you have this much when you divide plus this much extra. It's just our little bit of added pieces, parts, additional. Remainder, you can think of it as an additional part. Now, to kind of help us out with that, you guys saw the answer at the beginning. We were just supposed to verify that it's true, and we did. There is a quick little algorithm. You're not going to have to memorize it, but I do want you to write it. You don't have to memorize it, but I do want you to write it. Thank you, thank you. There is a quick little division algorithm. And technically, it shows all sorts of stuff. Like, if we have an F over a D, the F goes inside, the D goes outside. Has some of the particular names in the sense of who's the divisor, who's the quotient, who's the polynomial, who's the remainder. And it also shows what we just did. How do we write the remainder? Long story short, mathematically we should write it as a fractional piece of the divisor. And this is mostly for those for whom it's hard to start a problem when you see that division as to which one goes inside, which one goes outside, and those for whom it's a little tricky to think of once you have a remainder how to properly write it when we state our answer. How to properly write it when we state our answer. Just basically little formulas to show you how to set up the problem when you're given a division and how to write the remainder. And a quick reminder about the remainder. If there is a remainder, the divisor did not evenly go into the polynomial, which means we would also say the divisor is not a perfect factor of the polynomial. Are we almost there? Okay. We already did this example in the back of our spiral. Let's move on. Synthetic.
Yes.
Now, some of you guys love synthetic. That's awesome. Some of you guys, you think you like it, but you don't remember really what it is and how to do it. So one page and one page only, just as a quick little, hey, here's everything you need to know about synthetic. Then examples, and basically we're done, so we're super close. This homework is usually a nice one in the sense of pretty straightforward. It's just reminding yourselves of how to solve.
Why does this not always work?
Remember, we can only do synthetic, at least we can only do synthetic simply when we're dividing by, it's a little messy, dividing by x minus a number. We could almost do like ax minus b, but as soon as you have an x squared or an x cubed, if you're dividing like we did, if you look back at the example, we divided by x squared plus 5. That was illegal for synthetic. either be dividing by something with an x to the first power only, no squared, no cubed. Or you have to be able to break it down into an x to a first power factor. Now, as you guys are writing the steps, I do have two little quick clarifications over here, the names, as to what's going on in here with the steps. There is x equals a, and that is called a solution, or a possible solution, we probably should say. The remainder is not zero, it's not an actual solution or a full solution. It's a solution, and I'll say a possible zero. Once again, the remainder is not zero, it's not an actual zero, it's just a possible zero. So x equals a is a solution. X minus a is a factor. And technically, once again, if that whole remainder is not zero, I'm going to say possible factor. And just to connect it with what we did on the page before, we would call it a divisor. It's something that we're dividing by. X minus a, we're dividing by it. And it's a possible factor. It depends on whether or not the remainder is zero as to whether or not it is an actual factor, in a sense of factoring with a polynomial. Okay, this little asterisk is bugging me. Hold on. Somebody else want them in the box, because I kind of do. Let's get them in there. Oh, then he messes everybody else up. Gotta love formatting sometimes. That's why I didn't do it. Never mind, forget it. He's gonna stay outside. Okay, so we're gonna take the following problem at the very bottom of the page. It's a dividing problem. We could do long division, it would totally work. But we can also do synthetic because, what Tyler just asked a second ago, the factor is of the form x to the first power minus. Now, hold on, quick question. Do you think I could have a plus and it would still be okay? Yes. The plus and minus doesn't really make a difference as far as whether it's legal to use synthetic. It'll just change the number that goes in the box. Box, what am I talking about? Let's review. Let me dual page though, just so that we can do the example while looking at the steps, just in case you need a reminder.
Memories.
Now we remember. You guys just gave me blank stares for the last like 5 minutes. Okay, so. Here we go. Question. We set up the problem with the polynomial's coefficients. So hold on, I put the 6, I put the 7, I put the -1, I put the 26. No zeros. Why? I went from cube to square to single to constant. There's no other term to be inside. Right?
Yes.
Who do I put in the box?
Positive.
Positive 3. Do you see why?
Yes.
X minus A. I put A in the box, so therefore it's a positive 3. If you want to think of it as the opposite sign, just be careful. We have to take basically the solution to the factor. If we were to set this equal to 0, what number would we get? And that's a 3, and we plug it in and we're done. What do I mean by the next step? Carry the first coefficient?
Bring 6 down.
Bring the 6 down. Right? And what's your multiply add pattern? 6 times 3, put it, and then add it to be 25, right? Hold on, just a few. That might be new. The rest of you guys keep going. You know what to do, right? Multiply again. 3/4. Add it. Uh-oh. We need a calculator. No, you don't. Come on. Don't be lazy. Carry the 1 and we have 22, right? You can multiply.
I thought I was wrong.
3 times 74. 3 times 4 is 12. Carry the 1. 3 times 7 is 21 plus 1 is 22. You've learned that before too, by the way. You're just sometimes too lazy to do it.
248.
But the SAT doesn't always have a calculator.
Darn.
Just in case. Add down 248. Why did I put a straight line? Caleb, say it louder.
That's the remainder.
That's the remainder.
That's the remainder.
Nice.
Louder.
Now, thanks for encouraging confidence and answers come back. Since there were 4 coefficients to begin with, which denoted what type of polynomial? If there are 4 coefficients. Not a quartic. Why? One's a number. Then we have an x, x squared, and x cubed. So 4 terms, take off the number, 3rd degree polynomial. Because when we do synthetic division, the last one is just a remainder. Question, what kind of polynomial do I have now?
Trinomial.
Binomial.
It's a trinomial,
Come on.
but what degree? 2. Meaning, do you remember?
Oh.
That's now an x squared, that's now an x. We throw in the signs and we're done. Ricky, you good?
Yeah.
Finish.
Oh.
So remember, we start off with a 3rd degree, we divide it by a 1st degree, we're going to get a 2nd degree. Hopefully that kind of makes sense, especially if you think about this last one is a remainder, so we only have 3 now, it's going to be a quadratic. What does this mean? What's our final answer? Give me a second. That's technically the problem that we did. We get the 6x squared plus 25x plus 74 plus, how do I put the 248? 248 over who?
Minus 3.
Got it. Once again, is x minus 3 a perfect factor or even just a normal factor of the polynomial? No. Why? It doesn't go in evenly. But can you still divide? Yeah, sure. Why not? So you guys got it? Synthetic division? So then, what if I was to ask you, pause, there are notes, but I just want you to peek at the example. What if I was then to ask you to use synthetic division to find the function value? Okay, before we do this one, come back. Synthetic division, we only did one normal example because we're going to do some more synthetic division in a second, but here's an application of synthetic division. The remainder from synthetic division will equal the function value at A at the solution of the factor you're dividing. Now, that might not seem like a big deal, but it might make more of a difference if I was to say, give you something like f of 6 instead of f of 1. And we'll get there in just a second with our example. But first of all, write down your application of synthetic division. The remainder from synthetic is the exact same thing as the function value, no, it doesn't move, we'll move it down. The function value at A. So how do we find the function value at A? We plug x equals A. Remember? F of A, not F times A. You plug it in, no big deal. Some of you don't like the mental math. That comes from plugging in. Remainder. How do we get him? Well, synthetic. Or technically, we could say all division, including polynomial. We could say all division, including polynomial, but synthetic technically, or typically, I should say probably, typically goes faster. So if we're trying to use division to try to help us find factors that go in evenly, synthetic usually goes faster, and we're usually trying to divide by linear factors of the form x minus a or x plus negative a. Hence why synthetic once again is okay. Now one more clue, if f of a equals 0, look at this little statement above. Who else equals 0? The remainder equals 0. If the remainder equals 0, hey, it's the factors. So sometimes it'll be easier just to plug into f and say, hey, is it 0 or is it not? And not even worry about synthetic. But for some of you, or depending on the function and how hard it is to plug in, you might rather just do synthetic and look at his remainder instead of doing the plugging in and the annoying math, especially if you don't have a calculator. Or if you're like so many that have gone before you, and sometimes the calculator doesn't give you the right answer because maybe there's a fallible person putting stuff in. So as we come down here, use synthetic division to find the function value. You could just plug in, right? F of 1, no big deal. Plug it in, plug it in. For some of you, maybe still a big deal. But for most of you, plugging in 1, 2 times 1 cubed, that's mental math, right? 2. Minus 7 times 1, that's mental math. 7 plus 3. Some of you are like, 2 plus 3 is 5, minus 7 is negative 2. I'd rather just plug it in. Question. Would the remainder be negative 2?
Yes.
Would the remainder be 0? That's helpful. But helpful for what? Well, let me go ahead and show you. Who would go in the box if we were to use synthetic?
B.
F of A. And what are we using or what are we doing? We're dividing F by x minus 1. That's what that 1 indicates. By plugging in 1 to the function and getting negative 2, we can say x minus 1 does not go in evenly. And just to further cement what we're talking about, we would take the coefficients 2, 0. What? 0? Because there's no squared term, right? How does synthetic work? Bring down the 2. Multiply, add. Multiply, add, multiply, add. You guys keep going. I'll catch up in a second. Hey, looky there, it actually works. So when we plug in 1, we're figuring out the remainder for the synthetic division. So if it's easy to plug in, we can say, oh, hey, yeah, it's not going to work, it's not a factor. What's it? X minus 1. But then if we come over here, you guys okay? Getting really distracted. When we plug in 6, if we were to do the plug-in and chug-in, some of you are like, yay, this is so much fun, I love mental math, and I could totally do this and be totally confident with my answer. And some of you are like, not a fan. So those of you that are like, not a fan, we could maybe do it an alternate way. And we could say, hey, let's just throw that 6 in here and let's go ahead and grab our coefficients of 2 and 0 and negative 7 and 3. Let's bring down the 2 and let's do easier math facts to help us get to. Now, we have to do 6 times 65. Struggle. But maybe it's better for some of you than 6 cubed. 6 times 65 is 0 and 3. Carry the 3, 39, 390, 393. What should those mental mathers be getting from up above if they were to finish factoring? Not factoring. I apologize. Plugging in. Did you get the same answer? 6 times 6 is 36. 36 times 6 would be 6 and carry the 3 and 216. 216 times 2. 432. 432 take away. 42 plus 3 is negative 39. 432 take away 39. 390. Some of you, that synthetic was a whole lot nicer than all the stuff I just said. But still, long story short, is, wait a minute, who are we talking about as in terms of factoring if we're plugging in a 6? Who are we talking about? If we're plugging in a 6 and we're thinking about factoring? It tells us about who? It tells us the y value of the function. True. Maybe I shouldn't ask that. Maybe I should go to the synthetic division. When we're doing synthetic division and we plug in the 6, who are we dividing the function by? X minus 6. So when we plug into f of 6 and we get 393, or similarly when we do synthetic and get 393, either way we're saying x minus 6 is not also a factor. Okay, does that kind of make sense? Or technically. Let's see, is there anything else funny that can come? I think I just have like a page of work. Oh yeah, we were supposed to do on that page, that's okay. Ooh, here's one more. I'm going to give you different examples of how synthetic can be used, because otherwise you're like, whatever, synthetic, yay, got it, and then weird stuff comes up and you're like, eh. So if you wanted to show that x equals a is a solution, which means if this is a solution, that means x minus 2 is a factor. You might not understand everything they're asking, but don't you understand we use synthetic part? Who goes in the box? Go. You have not yet. You might not understand the whole problem, but you can read the use synthetic division, so set it up. A is 2. Anyway, just disappeared. I disappeared. It disappeared. You guys, a couple more seconds, then I'll swoop in and do synthetic 2. Little things. Hopefully use the coefficients 1, 0, negative 7, and 6, yeah? Remember your 0? Who'd you throw in the box? Uh-huh. No one's annoyed by my line, so am I. What? Bring it down, multiply, add, multiply, add, multiply. How do we show it's a solution? The remainder is 0, of course it's a solution. How do we factor it completely? I don't even see factors. I can change like this. And technically, I could rewrite what I just did. X cubed minus 7x plus 6 all divided by x minus 2 is equal to x squared plus 2x minus 3. And I could move the x minus 2 to the other side with multiplication and say, hey, look, guys, I'm factoring. Last year, though, you might have, for this whole factoring thing, just stolen the 1 and the 2 and the negative 3 and rewritten it as coefficients and then started thinking about, I wonder what goes in. But in this example, since it's a quadratic, if it's a nicely factorable quadratic, maybe you don't need to do that extra step because you can look at them and say, I know what to do. How do we factor x squared plus 2x minus 3? X with a 3 and x with a 1. Which one's negative, which one's positive then?
One's negative.
Yeah, I need that 3 to be positive to get a positive 2. The 1 will be negative. I have my x minus 2, and look, I have all the factors of a cubic trinomial. Well, technically it's a trinomial, but a cubic polynomial. It was a bit harder than the ones that we saw in section 2.2, right? A little bit harder? In section 2.2, how were those ones easy? They had common factors. You were able to pull out an x, you were able to pull out an x squared, you were able to get it down to a quadratic without any of this work. Now guys, what made this problem nice? What did they tell you? They gave you a solution. They said, hey, 2 works, aka x minus 2 works. they gave you how to start and they gave you the first step. In section 2.3, they're gonna keep doing that. They're going, if you need to be factoring, they're gonna be giving you a first step. However, what if they were going to give you something instead, like the following? Which, once again, it's not gonna be in this homework, but it's coming soon to a math classroom near you. Factor
People just think that way.
the following. And that's all they give you, along with a function. F of x is equal to 2x cubed plus 3x squared minus 8. And they don't tell you anything else. How do we use what we just did to be able to start trying to factor?
So it's just that.
What do we do synthetic with? What? Yeah, you gotta guess stuff, pretty much. What are gonna be your options? Where's my eye? There it is.
One.
We can try 1. Oh, we have to start doing synthetic with 1? Wait, isn't 1 easy to plug in?
Yeah, just one,
So couldn't we test
2 plus 3.
1 just by plugging in? And say 2 plus 3 minus 8 plus 3, just to double check before I do all the work of synthetic.
Oh wow, that's actually.
5, 8.
Whoa.
Why am I going to do synthetic with 1? Awesome. Now what if we were checking instead x equals 3? Would it be as easy to plug in?
No, better to do synthetic.
So maybe some of you would want to do the mental math of checking first, but some of you are like, forget it, I'm just going to try synthetic. If it doesn't work, whatever, it didn't take that long. But the nice thing is we know this one works, right?
Yeah.
Because you guys just happened to choose the right one. If you had chosen negative 1, but if you had chosen negative 1, maybe it wouldn't have gone as nicely, or 3, or negative 3. But we'll see. So to finish off today, factor completely. Go. But you guys did choose a nice one to start. All the factors that you can. You guys talking already done? Let me see. Lesson if you need to go to bed.
Oh shit.
Yeah. So now you have x minus 1 plus 1 part to the factor. You know what I mean?
Yeah. I got you.
You got here, that's great, but you're not done.
Yeah.
Which you can say. You broke it down. What do you still have to do?
Get the factor, I got it.
You have to factor him. And if you're ones that don't like the number in front, whew, good thing we practiced this recently. Multiply the first and the last and think about who on earth can work. Ooh, -2, negative, oh, that doesn't multiply to be a negative. But I can do -1, +6. Break it down a little bit, -x plus 6x minus 3, 2x. So if I were you, I wouldn't stop writing the x minus 1 or else you might get lost somewhere in the process. How did I find who?
I got you. Just take that out, just take the S.
Right here? I just used, those are the only factors that work, so I split it up with grouping. Then I'm gonna go ahead and get my 2x minus 1 plus 2x minus 1. X minus 1 is doing his own thing out there. And I end up with 2x minus 1 times x plus 2 times x minus 1. And Nathan, I heard your question right. What part were you missing?
No, the x minus 1 on the final fact, the last.
Oh,
Yeah,
that's who he was, remember? So when we divided,
I took that W.
we got this, and I just moved him over to the other side. So synthetic means dividing. Okay. Educators.